Okay, so when we talk sustainability, so there is the intersection between people, planet, and profit, which is, as I mentioned, wider than the environmental aspect alone. When we talk about people and profit, so it's this kind of a fairness. And when we talk about what else? Okay, when we talk about planet and profit, we are talking about viable. What does mean? So we have livable, the intersection between people and planet. So what I mean livable is worth living or fit to live in. Okay, the intersection between people and the profit, there is fair. What does mean? It means treating people equally without favoritism or discrimination. That's what is known by fair or fairness. The other things, what is it? Viable, which is the intersection between planet and profit. It means able or capable of working successfully or feasible. Okay, this is the intersection part. So remember, sustainability, it not only include environment, it also include social aspect and the economical aspect of it. When we talk about your cost is the time method is life cycle energy consumption. If we want to have the general information about life cycle definition or concept, so it has 3 components. So here, life cycle sustainability assessment, so which I provided the short brief information in my this slide. So it includes life cycle analysis. This part it's linked to the environment, and also it includes the cost aspect. So it's life cycle cost, and also it includes the third aspect, which is the social aspect or people. So here is the third part of it. This definition or the 3 components have been set via ISO, via standard, international standard, so which take into account the 3 components of life cycle sustainability assessment. So the ISO compliant life cycle assessment is the most reliable method to verify environmental impact and support claims, since it's linked to the environmental impact, especially for SAI. It provides designers, regulators, and engineers, as all of us, with valuable information for exploring decisions in each life stage of, for our case, form of materials, buildings, services, and infrastructures. However, life cycle in general, it doesn't only apply for building. It can be applied for any for many things or for many products. So it's not like designed for building only. So it may apply for various things which have the 3 components. So the life cycle analysis, the first 10, life cycle assessment, identify environmental hotspot in products and materials, and establish the benchmark against which improvement can be measured. I have a product, for example, or a company have a product, they want to assess the life cycle assessment. Probably they have a benchmark, like someone, a reference to compare the product. How good is my product compared to a reference that is selected? I can even use the first stage. Probably I just criteria, the life cycle assessment. At the next stage, probably after 2 years or 3, I have already the information or the data there. Probably after a few years, I want to improve the environmental impact of my product. So what I do, probably I change a little bit some of the materials in terms of, also I change in terms of transportation and so on, etc. So here there will be my benchmark. I compare it to my initial one. The first one, I already know how much, or I estimate the life cycle. I do already assess the life cycle of the product. So then which is my benchmark, and then I add to it. Means I go to further improvement. Okay, so we have life cycle assessment, life cost cycle, sustainable life cost. I am not sure what is it assessment. Okay, it said it saved them. It helped me. So environmental life cycle cost. And still to read here, I have other probably is better information. Okay, we start by it anyway. It describes all costs associated with the life cycle of product, so the price, that are directly covered by one or more of the actors in that life cycle. Thus, a cost must relate to really money flow. So what does mean? Life cycle cost is a technique. The purpose of it is to estimate the total cost of a product, for instance. We call it general ownership. It's a system that tracks and accumulates the account cost and revenues attributable to cost object from its invention to its abandonment. So the most important part, it takes into account all cost of acquiring, owning, and disposing of a breeding or breeding system. If I take it into here, the cost will not be only the cost of the product. Even after using the product, I will take it into consideration. And at one time, the product will be, if the breeding will be disposed or demolished, the demolition parts still require money, still require energy, and so on. This one also is to be taken into consideration. So anything related to the cost. The third part is societal life cycle assessment, which is a social aspect of life cycle assessment, which is the most complicated one. In fact, it's not the most complicated. There is little information available about it because it's quite recent. So it started about early in 1990. So, but it's good to know general information about it. It's supposed to take into consideration other factors which link to the social aspect, including health, for instance, safety, human rights, working conditions, socio-economic economic repercussions, cultural heritages, and governance. So anything linked to social aspect. Sometimes in the calculation part, the SLCA in many cases is ignored, but indirectly is included in life cycle assessment in the environmental part. Okay, while you are learning it for civil engineering and the advanced environmental engineering, as you know, like breeding consume energy during each stage of their life cycle. So starting from the time when you breed start breeding, for instance, you do need the material. Material doesn't come just grown naturally. If you have contract, for example, means the contract, it has 3 elements or 4 elements. At the same time, the contract, the preparation, probably you need to, not probably, you need to buy sand, you need to buy gravel, you need water, etc. And also it requires transportation. So any aspect linked to the transportation, linked to the material, to the construction, even after during the time of construction, after construction, people will be living, for example, in a house, is to be considered in life cycle analysis, and in some situations, including, as I mentioned, the demolition part. Each part of it should be considered. Why? Because I may breathe, I may construct a breathing. I claim this is very green. Within, I can also claim that is based on means it doesn't consume a lot of energy. But probably your product, the material that you are using, probably it is not, probably it's environmental friendly, but it's not from, for instance, it's not from Malaysia. Probably you export it or you import it from US, which is far away here. So the transportation, it will affect the environment overall. So that, for that reason, it should not be ignored. Means even that is, so if you have like a local product, for better in terms of life cycle analysis, but not necessarily always the case, rather than export from outside. But sometimes the situation is different. What does mean? You have to take the stages from material to production, through construction, operation, the time when people are in the breeding, refurbishment. Refurbishment, I wonder, okay, I provide it now. It's the renovation and the redecoration of something. Usually is ingredient. It has a key role to play in the change of use. With it may require renovation. It may require redecoration. It may require you change the space as house at 50, you decide to convert it, for instance, in terms of life cycle analysis. So this is a very complicated, quite challenging topic. But anyway, for us, you will have only a very brief introduction, which helped a lot and give you a better insight about it. So as I mentioned to you, even after the reconstruct of building, the demolition and disposal part should not be ignored. Yeah, I wonder how are you doing? Okay, Rashid Hamad, sorry. Hello, Rashid. Okay, are you following? Are you okay? Are you tired? No, are you tired? Why don't you be tired? Do you hear me? Hello, guys.
Yes,
Oh,
ma'am.
no. Yes, I'm hearing you. Nasha, okay, receive it. You are okay. Oh,
Okay, doctor.
okay. Uh-huh. Doctor. Okay. Body right. All right, Rashid. Hamad. Okay. Yes, doctor. He just arrived. You are not tired. You are not supposed to be tired. Engineers, actually, in fact, uh, probably this information provided in this slide is extremely important, and it shows that life cycle analysis is a very important topic, and I believe is for in civil engineering. Why? Because civil works and building construction consume 60% of raw materials extracted from lithosphere. Yes, 60% of raw material extracted from lithosphere. Can you imagine that? This one for only civil work and the building construction. Okay, from this volume, building represents 40%. And what does mean? You take 60% of the lithosphere, of the raw material. From the 60, you take 40% from it. It's just linked to the building itself without including civil works. When we talk about civil works, we may include telecommunications, pipelines, sewer, water treatment systems, highway, roads, bridges, etc. So here 24, it's obviously it comes 60 times 40 over 100, so we find 24 of that's total extraction of the lithosphere. And you see, I believe you agree that it requires a huge amount of energy, not only during the construction stage, even after construction, where people are living in the house or in the building or staying in the building, regardless of, it will consume a huge amount of energy, including like university offices, regardless of the place. You need photocopy, you need light, we need a lot of amount of energy. And in fact, the amount of energy during operational stage is higher than during the construction stage. Yes. So I repeat one more time. The energy, the amount of the quantity of energy consumed during operational stage is much higher compared than during the construction stage of the building. Even though during the construction stage of the building, we do building consume, it requires a lot of amount of energy. Why and what is the life cycle assessment? So we add a little bit more information about, as I mentioned in my first slide that I will add to it. The life cycle focus must help decision making. So when selecting the best technology available and minimizing the environmental impact of the building through the design and the refurbishment. Among the impact for decision making, if you want to minimize the amount of carbon dioxide in the atmosphere, there is no better than taking into consideration the life cycle assessment of the building. Sorry. So it helps in decision making, even like for at a high level, even at government level. Life cycle also it will be very helpful. For example, if there are many types of building materials and want to assess the entire schools, for instance, in Malaysia, it's good to do life cycle analysis by selecting few buildings to use them to see which buildings are performing better in terms of environment, in terms of sustainability compared to others, and use it as a reference, for instance, for 2020 and later in 2025 or 2050. You can always use the first one with your benchmark. You see how far you manage to improve things along the years. Okay, we continue about the explanation linked to life cycle assessment, which is the first part of the ISO standard relevant to life cycle in general. So life cycle assessment, which is linked mostly life cycle assessment to the environment, also known as life cycle analysis or ecobalance, is a technique to assess environmental impact associated with all the stage of a product life from cradle to grave. I draw it here, but it doesn't mean, it means from the time, I show it here, since you are engineers, so the time you come the first time period construction, the site will describe this one. So this one is supposed to be from cradle. You do the assessment from cradle to the demolition part, the last part, to grave. So what does it mean? From raw material extraction to raw material processing and manufacture, distribution, use, people will be using the breeding, repair and maintenance, and also disposal or recycling. So that's all about, again, life cycle assessment. This one is a very good illustration for it. Okay, I left few slides that for you to read by your own. Whenever we talk about life cycle in general, as I mentioned, we talk about environmental and impact. You observe in some slides, I believe probably even in the web, in fact I take this one from the web, there is no, it doesn't show the social aspect of it. But as I mentioned, whenever we talk about sustainability, the social factor should be considered. Here, why I want to select this one is example of breeding life cycle from cradle to grave. We start by raw material. Product manufacture, transportation, construction stage. Before the breeding is a birth of the breeding cell. Okay, so let us provide further information about stages of the life cycle of a typical breeding. So you are supposed to remember it. So what is it first? Energy consumption at design stage. If I am in the class, I will ask you to repeat it without looking at the slide, which I will do it. Energy consumption at the design stage. This one for breeding. Energy consumption at the material production stage. Energy consumption at the construction stage. Energy consumption at the operational stage, energy consumption at the refurbishment stage, and finally, energy consumption at the disposal stage. So we start design. Of course, before you build the construction, you are supposed to design, engineer, you are supposed to do all the required calculation. And in that stage, you will need electricity, you need the laptop, whatever you need for the calculation part is supposed to be energy consumption at the design stage. What any linked to material is supposed to here. So this one is not all details, but are the main things that should be considered in general. So design stage, material production stage, construction stage. When you talk about construction stage, even when you are engineer visiting the site to see the usually when the construction stage, there will be office in the site itself, and there will be most likely engineers where they sit most of the time there, and they will use energy like at least lighting and whatever it is. Also, it's supposed to be included at the construction stage. This absolutely will not ignore any aspect of it. Operational stage, I explained before, is the time the pupil occupy the building. Refurbishment stage, as I mentioned before, like example, renovation, not necessarily only renovation, redecoration. Probably you will change the space from the functional aspect of the space, etc. and we have disposal stage. So to get a read from the breathing material. All right. We are still in introduction. As I mentioned to you before, operational energy account, after the construction of breathing, the pupil will occupy the breathing. So during that stage, after completing the construction, where people occupy the space until the demolition of the building itself, any energy consumed during between us is considered as operational energy. It takes accounts for the main amount of total energy used, for instance, in dwelling houses during an assumed surface life of a building. For example, 50 years, but sometimes building can go up to 100 years. Of course, depending on building materials, if you build a house, wooden house, it doesn't have the similar service life as concrete house. So the operational energy account sometimes it can go up to 85, from 85 to 95% of total energy use. This is very huge. For that reason, currently there are many, you hear many talking about energy efficiency, lighting efficiency, anything linked to inside the building. It's very important to be considered, and humans should be taken into consideration because people behavior will affect automatically the energy consumption in the building. The content that the focus is started is like people behavior and how they use energy in their building. However, the construction stage is also very important as well. Okay, this one is like example. I take it from the publication. So you have product stage, consumption, and etc. You may just have a look for it at it. Sorry. Okay, are you okay? Fazina, James, how are you? Hi, there's two under the same name. Why? Are you the yeah? This who is the first? Who is the second? Why these two names?
It's
Two
the same.
the same. Uh-huh.
I'm using my phone and computer, my laptop.
All right. Here, Karim. All right. Okay. Are you okay? Are you tired? I talk a lot. I prefer to stop a little bit because I tend when this presentation, when there's a lot of talk, I prefer to stop a little bit for about like 5 minutes or 10 minutes, at least to relax a little bit. But meanwhile, you can ask me a question if anything you want to share. As well, you plan to ask something.
No, doctor.
Okay. Apa kabar?
Good. Kabar baik.
Okay, sama-sama. Okay, I can see here. I am not sure how I didn't manage. I have. I start to see the name of Ibrahim Ben Yasser, Annie Aryan, Fazina James, Azwa, Rashid Hamad, Fazina James. As I mentioned, these two, Isabel, and Fatin Munira. There's another name. It's hidden somewhere. Okay, Fatin Atika. I know that you are 26 is already here. I'm aware about it. So that's why I cannot see thy name. So I hope you are fine and well and enjoying your time with us. All right. All right, Rashid Hamad. Can we pass to the next? Hello. Are you here?
Yes, Doctor.
Yes,
Okay.
doctor.
Hello, Karim. Hello, Rashid Hamad already. Hello, Fazina already. Samur, Sida, Samir. All right. Okay, La. Okay, La, we continue. So this one you can always have a look later. This is a good illustration about life cycle construction. This is a real case for your information. This one was made in from Japan sources, references, but it's a real case. Here you observe, if you have example breathing, you see the design stage, material production, you see the construction part, how the cycle energy, the amount of energy used. You see operational stage, can you see how big it is? You see the power at the end, electricity, all is mostly, I wouldn't say all, mostly consumed at operational stage. You see, even refurbishment, it should not be ignored, because at the end you have to pay for it in terms of life cycle energy, or in terms of energy. Demolition disposal stage, you see here. Of course, here it looks small. It depends on the type of the building, the way how it was constructed, etc. Here, material production, you see, is still quite important. I believe this one probably insulation. Probably not all places they use insulation materials. So then it's interesting to have such information. You already know where you have used most of the energy. Next time, for instance, if you want to construct a new building, you can always know which part you are supposed to reduce the amount of energy. The design is not that high, but still should be considered. You observe in operation, even waste and sewage works is included in the calculation. Okay, so we pass to the energy consumption at the design stage. Okay, so at the design stage, it includes energy used in the design of aircraft. Anything at the design stage, as I mentioned, if you are engineer, there are architects, in your life they are sharing probably one office or many offices. They will be using inside the office like consultant. They may use IC, air conditioning. Most likely they will need lighting. They probably most likely they will need laptop. They will need other instruments, including the transportation is supposed to be considered at the design stage. Means nothing is left to chance. Everything is estimated in life cycle analysis. So the energy consumption at the design stage, which is shown here, design stage, the amount is not that big, but still 1%, depending on the units of the total life cycle energy of a building, and is almost too small, because if you compare it to 100, you would say it's still small. Okay, so but then it's supposed to be considered. Okay, so now we pass to the material production stage. So again, it's, even if you what we call it, you import a product, you are supposed to search for all the sources of the product, origin of the materials, etc. So even if it's imported, still supposed to be considered, transportation and so on, including the equipments. Equipments means for the materials, by the way. So at the construction stage, So one, of course, there will be certainly machinery or lot of machinery, the site office, etc. For me, site office is supposed to be, this one is different. Design stage is the consultant, the one who do the job in the office. The other one, they do the job at the location, at the site. So it's different. So here, there will be office, there will be machinery, there will be other items as well. All should be considered at the energy consumption at the construction stage. So we also include energy used indirectly by related business activity of construction companies, meeting, anything else. Okay, this is an interesting table. Is known by the industrial correlation table. Okay, here you see this one again is from a Japanese study. The energy consumption, you observe here there are various types of buildings, offices, houses, schools, factories, etc. And they are constructed using various building materials as shown in the slide. And you observe that the intensity of energy consumption, so the amount of energy consumed, you observe if you compare between a factory made with wood and the office made with reinforced concrete. Okay, so here you observe it's 15,835, whereas made with wood is 2,858. Of course, it cannot be compared. It's obvious that the factory made with wood is, in terms of energy intensity, it has less effect than the one in reinforced concrete. However, you should take into consideration the duration of the building, because at the end, the study is supposed to be from cradle to grave. So if the wooden house wouldn't stand for 100 years, probably concrete building may stand for 100 years. Also, the wood sometimes is subjected to decay or whatever it is, the deterioration fast. Other factors should be considered. But it's known that office means the building material made with concrete are not environmental. They have some environmental impact compared to building made with wood. I want to refer to something. All right. How the calculation from this table was made? It was created by calculating the total energy consumed in constructing all new buildings. So there are various types of building, as I mentioned before. As I mentioned, this type of map is now the name is in industrial correlation table. You will observe the steel reinforced concrete, which is the first one. It consumes almost 6 times then the lowest value, which is wooden factory. So if you do the proportion, you divide 15,835 over 2,858, you observe it's almost 6 times. The difference in terms of energy is 6 times. So which is almost, I think that's all for this part. As I mentioned to you before, even though it's very known fact that wood didn't affect considerably the environment compared to concrete, however, there are other factors which need to be considered, which I show here. If I take two materials, material 1 and material 2, I want to calculate the amount of carbon dioxide generated from the material 1 and material 2. There will be always a replacement stage. Here you observe a replacement. as shown. Here you observe replacement stage. For example, the material is not specified. It's a general information. The material, the replacement of the material, the replacement for the material 1 is higher than for the material 2. So even though material, but anyway, this case, even though the material 1 at the production stage didn't generate a lot of amount of carbon dioxide compared to material 2, which is obvious. Can you see the dark blue here and here? But at the disposal stage, at the end of the breeding, it ended to be material 2 is much better, or in terms of, it emits less carbon dioxide by meter square compared to material 1. So that's why the reasons are very important to take all of it into consideration. So we started by design, material production, construction, and now we move to operation. Construction I provided overall for the materials. It's supposed to be material, but construction also is supposed to be considered. I did provide explanation before, like for the office, for the machinery, etc. So as we mentioned, we already know operation of power. Obviously, the wheel will consume huge amount of energy at operation stage, which makes sense because the duration of operation it's longer than other stages. Okay, so it includes the directly used, the direct energy used in a breeding, including this one, for example. I see this one, the one that I mentioned to you to do the calculation for your assay, for your mini project, by the way. I want the external drive is all right. Here it includes example, air conditioning, lighting. If we are in the office equipment that use indirect. There are also like indirect use of energy. Example, water. You need to pump the water and sewage disposal and treatment. So that can be also considered in life cycle analysis. Example, cleaning equipment maintenance and ongoing repairs. So operation it's needed to what occupant of the breeding needs. This one in addition to other and direct use of energy. Example for water and sewage disposal, etc. As I mentioned, usually of the operational stage, the energy used is very high, which means it's very important to achieve energy saving design at operational breeding. If the energy life cycle analysis excluded the operational of breeding, the energy generated from it. So even though it's important because you need to know also how much energy is consumed at the construction stage, but for the overall, at the end, the energy consumed at the operational stage should not be ignored under any condition. Okay, so again, we return back to our life cycle energy stages. At the design stage, material production stage, construction stage, operational, refurbishment stage. Okay, so here it's not doesn't provide all the details, but I provided I explained it previously. It also includes interior and exterior finishes of breeding, given that they are typically renewed. Physical degradation, you need to do some reparation. It's supposed to be considered. Anything linked to maintenance, probably someone need to reconstruct a wall, whatever it is, still to be included. Equipment should not be ignored as well during the refurbishment stage. Given that the long lifespan of a building can go, as I mentioned, up to 100 years, so they will be subjected to various changes and deterioration of some part of the building, which need to be renovated. So if you take example here, the recommended service life of a building, for example, home, office, institution, teaching and culture, can go up to 100 years, as in let's contract, for example. Other things like leisure buildings, like warehouse, transport centers, probably 60 years. Some situation is less than 60 years. I believe you agree with me. Smaller buildings for storage, example, garages, carports, etc., it's 40 years. Again, so we return back to the stages. Design stage, material stage, construction stage, operational stage, refurbishment stage, and finally, disposal grade stage. Okay, disposal stage. So this where all the materials done, you should keep your side. Okay, at the initial stage, it was the location was something as shown in this slide. At the end, after the demolition stage, you are supposed to be the same as previous at the initial stage. And now you have to estimate the energy consumed during the demolition stage. And then the design itself, including the building materials, etc., have effect in terms of the amount consumed. So I read it. Energy consumed when a building is demolished includes, but also in when a building is demolished includes in reclaiming not only fuel. Means you are supposed to consider into calculation fuel for demolition machines. Since you will be using to demolish, you need machines. So the fuel supposed to be considered. Transportation, you need to do it. For any processing, you need it, including recycling. Sometimes you may need energy. It's supposed to be taken into calculation. Now, what I want you to do to make it more interactive, okay, so let's see how is your memory. So I ask you a question. The life cycle energy, the stages that I mentioned one by one, can you help me tell me what are those? I give you the first one is the design stage. What is the next one I talked about?
Material production stage.
Material production. All right, Fatiha, Fatin. Just perfect. And what is the next, please?
Construction stage.
All right, as well, just perfect. So the next is construction stage. What is after construction stage? Anyone remember it? Okay, Rashid. Op, okay, no, okay, just perfect. Rashid and Noor Miraza, operational stage. And what is after operation? Once the operation is done, so what you are supposed to do, you have to take care about your building. How you do that? probably it require maintenance and so on. Reformation stage, right? Okay, so what is the last?
Disposal stage.
Just perfect. The last one is disposal stage. Do you need the rest 5 minutes or 10 minutes? Yeah, I promise you I am fine with both, but if you are tired, I can provide time. So we continue. I assume that you are okay. All right, I will continue. All right, so let us return back to our slide. Okay, now we start another definition. I need to also to arrange my slides. Okay, now we start about embodied energy. Okay, so here, what is the difference? This one, the embodied energy, it looks the same as the life cycle cost. However, we take off from it or the operational and disposal of the building. If you are, for example, engineer, or if you have a company, you may not have any information about the operational or disposal stage of the building, but you can do your calculation quite good enough until refurbishment stage. So you just take off the operational and disposal of the building. So if we take off the operation and disposal of the building stage, it's known by embodied energy. So embodied energy is the energy consumed by all the processes associated with the production of a building, from the mining and processing of natural resources to manufacturing, transportation, and product delivery. But if you to have less charging inside your brain, so the easy way is the entire stages. For instance, if I take a building of the building, just take off, don't include the operational stage and disposal of the building material. For some, if I have a company, for example, probably I would be more interested to know about embodied energy of whatever it is of a product, rather than to go to disposal and operational. But if I am, if the person is in, like, if the government decision or whatever it is, upper level, of course, you would spend a lot of money during operational stage. It's not supposed to be considered, and disposal also should be included. So embodied energy. So probably I have another definition somewhere. Is the sum of all energy required to produce any goods or services, considered as if that energy was incorporated or embodied in the production itself. It's linked to the product, it's embodied in the product itself. So for that reason, we can, when we talk about embodied energy, means we already excluded, what is it, operational and disposal of the material. The way how to calculate it is here. Here, example, if you take embodied energy of some of building materials, So it can be provided in per kilogram or per meter cube. Here you can observe contrast block, contrast 30 megapascal, contrast pretest. You can see the differences. Sometimes you may have many choices to buy a material. Probably, so sometimes probably you will take it into consideration. So here, aluminium recycled, for example, is 8/1. I am not sure if there's aluminium here. You can always compare to it. Aluminium is 227. However, aluminium recycled is 8/1. However, I highly recommend to you to read carefully about that one, because sometimes it looks interesting solution, but probably they do have impact to the environment, negative impact to the environment. Even like recycled one, some they may be poisonous, like stainless steel and other materials. Probably you have to, in terms of environmental effect, probably they affect negatively the environment. But in general, overall, it's good to have various types of materials and the embodied energy. If in general, for a company, they're supposed to have their own database. The company have their own records. And sometimes when they cannot find their own database, they may ask other companies for their data just to do a rough estimation. And sometimes they may refer to other references, probably books, probably publication in the web, but probably, most likely, it will not be as accurate as the company own data. Because later, if they want to improve their product by considering all the stages of life cycle, they have their own data and reflect the true case, and they can truly minimize the environmental impact, including minimize the energy consumption. Energy is money at the end. Okay, as a rule of thumb, I just highlight this one. Embodied energy is a reasonable indicator of the overall environmental impact of building materials, assembly, or system. Okay, this is another observation. This is supposed to be started from here. Embodied energy may not be significantly different between building systems. Probably not. There's a term made. You have to be careful. Not necessarily is correct. Wood versus concrete. Probably in some cases you may find it's not a lot of difference. However, the environmental impact associated with one material versus another can be drastically or dramatically different. In terms of energy, probably the energy usage probably is almost the same, but the impact of the building materials itself, the environment, probably it's different story. So environment and energy both are supposed to be included. I will add other information about later on. Okay, I believe this one you will like it. It's kind of large information, but it's a relaxing information. But it's all about life cycle. In fact, I didn't provide all details, and I am not trying to teach all. But the part that I will be teaching is supposed to be at least needed for your final exam or your thesis. I will not cover it. I think that's it. Okay, the first things what you should know. I think we discussed about it before. I show you the two types of building. Probably one at the production stage, they may not use a lot of amount, for instance, of energy, but in refurbishment stage, probably one of the material will be using more than the second one. So you should not take into consideration the short term in terms of selecting a product, but you are supposed to take into consideration all the stages. So I read here, often products that are presented as cheap in the medium term can have high maintenance or waste management costs, and highly technological products can have very high production costs that are never recovered. Other than it's very simple. You buy your shoes for 1 month, probably it costs even 10 ringgit. You buy your shoes for 1 year, probably it costs 100 ringgit. When you compare the prices for 1 year, it ended to be the same. When you, in terms of wastage, the cheapest one will waste even more energy and more materials and so on. So that's it. Energy behavior in several building materials have been investigated, outlining the importance of using recycled and natural building materials. Of course, because it will cost you most of the time, it will cost less energy. However, this better than recycling is reuse. You reuse it. If you cannot reuse it, you do have to recycle it. Natural building materials tend to have the least effect in the environment. I need to because I have like my PowerPoint, I think as a version. I need to refer to the next slide before. Okay, you may read the following. I will not do any comment. So you observe there is always saving. Probably some students that are doing fly hatches in their lab or in their FYP study. So if there is sometimes when you do substitution, even a small amount of the material can do some saving. It can do, for instance, up to 20% of the cumulative energy over 50 years life cycle. Whenever possible, recycling, of course, it's important to be taken into consideration. As I mentioned before, you have to take as well the environmental aspect of it. Sometimes it may have a negative impact on the environment, which is better to minimize the usage of it, not to ignore, to avoid it at all, minimize it to the least possible amount. This is a nice case of recycling. The building after construction. It's a very well organized. This is a well case of using recycling the papers here. But I wonder what's the purpose of it. Probably we'll cover it later on. I'm not sure why they use it this way. Insulation material, probably it works. But other negative aspect, I didn't go through the sources where they do it. I believe it may have environmental aspect. Again, like this, when we build a construction, it requires a disposition stage. You can always reuse it. Example, concrete, crushed part, bricks can be always reused for roads, etc. I have some illustrations which I show later on. I didn't read every aspect of it, so you will have a time also to go through it. This is an example about the importance of wood starch. Usually it generates less CO2 and it requires less energy for the quantity of concrete. This is a case of wood. This is an example of crushed concrete and fly brick. You can be used as cross aggregate in routes as substitute for gravel. So this is a very beautiful illustration of it. This one another illustration for the bricks. A beautiful one, in fact. This one example of a recycling contract payment material. I didn't have a nice illustration, but that's the recycling part, which is nice. Okay, so I think we still have few slides probably only. Okay, how are you doing? Apa kabar? It's raining in Kiki. Can you hear the sound of rain? All right, so it's heavy rain, by the way. Do you miss anything from Kiki? Or you are staying, or you are living just close to Kiki? He's sleepy while raining. Oh my God! I cannot stop rain. Ha ha ha! I agree with you. Yeah, rain, please stop. My student will feel. Okay, I will close the windows so that you will not feel sleepy. I close it. Can you hear the voice? Oh, I feel half harness. I need to switch on aircon. I am not supposed to switch on aircon. I am teaching something about life cycle analysis, but I truly feel harness. Okay, Nor Azima Ali Zawati. Ha 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 ha. Okay, how are you doing? Are you very busy? Rashid, Hamad, why every time you come late, you arrive late? No, nothing. So we return back to our course, right? Yeah, I would. Can you hear my voice? Hello. Hello. Apa khabar? Okay, thank you. All right, so let us continue. As I mentioned, most likely I will finish a little bit early because when I provide without application, it looks a little bit tiring. I do have. I want out. I reaching late. Okay, okay, Rashid. All right. Okay. So I take off part of the chapter because I am providing a lot of it in reduced time. So part of it I already excluded. I keep it in the PowerPoint for your reference because last year I do application example, quite a lengthy example, not very lengthy, but takes time for the calculation. I included even in the final exam last year, but this time I decided to take it off again with not only for time limitation, but also not only for my time limitation for the explanation, but also for your time to absorb the information. So I think that's it. Okay, Rashid Hamad, thank you for the message. We continue our slide. Okay, so you can, of course, all of you know what does mean carbon dioxide. I wonder if all of you know the meaning of global warming potential and the time to explain the meaning of global warming potential. However, before I explain global warming potential, we are supposed to talk about global warming. What is global warming? Okay, any explanation, please. You can write it a comment. You can even talk. What is global warming?
Increase of temperature.
Temperature, yes, is good. Temperature of what? Increase of temperature of?
Surrounding.
You are right. Okay, I add to your explanation. So global warming is the ongoing rise of the average temperature of the Earth climate system. The average surface temperature, the average temperature of the planet Earth, there is the rise. So we call it global warming. You have to find the distinction between global warming and heat island effect, which I explained it in chapter 2. It is a major aspect of climate change, which is, in addition to raising global surface temperature, also includes its effects such changes in precipitation. When the global surface temperature of the Earth change, also it affects the precipitation. Hujan, the rain, precipitation is also affected. So not only temperature is affected, rain is affected, and other environmental issues have been found due to the rise of temperature. So when we talk about among the indication of global warming, most information, in fact, for global warming, I will provide it in the next chapter linked to carbon dioxide, because somehow they are linked. They will have full chapter only for carbon dioxide. But then you do need to know for now, because it's needed for the life cycle assessment, you do need to know, so we know what does global warming. So global warming potential is the heat absorbed by any green gas in the atmosphere. Do you know what does mean greenhouse gas? It means it's not only carbon dioxide, other types of gases which are greenhouse gases are also considered under global warming potential. Why? Because by definition, global warming potential is the heat absorbed by any greenhouse gas in the atmosphere. So how do we calculate the global warming potential? We have, when we measure any that's close to me, I may use a tape. I need the unit of measurement. Am I correct? My unit of measurement, probably I decide to use centimeter for convenience. It's easy to do calculation. Global warming potential, it has unit of measurement. The unit of measurement of global warming potential is carbon dioxide. Carbon dioxide is one of the gases behind one of greenhouse gases, which causes global warming. All right. So I show you in the slide the global warming potential. There are many types of gases that contribute to global warming. Example, carbon dioxide, methane, nitrous oxide, etc. I'll show you some of it then. The unit of the global warming is carbon dioxide. So it has one unit. Methane affects the global warming when I compare it to carbon dioxide 21 times. Means the effect is more higher 21 times than carbon dioxide. Yeah, but given that global warming potential is the unit of measurement is carbon dioxide, we always provide the equivalent of it. We use the term global warming potential. So I read here this list that may expand your mind a bit. This table relates each gas by its global warming potential. For instance, methane or CH4 has a global potential of 21 because it has 21 times as powerful as greenhouse gases as CO2. Probably a factory produce, I give any example, 10 methane, which does make sense, 10 methane gas units and 10 carbon dioxide. If I want to do the overall calculation, I will do 10 plus, if the company produces 10 methane CH4, so I will do plus 21 times 10 to calculate the global warming potential. Obviously, this means that I believe this one is the best example, the one that I read it now. I am reading it. This means that for 1 kilogram of methane, every 1 kilogram of methane is equivalent to releasing 21 kilogram of carbon dioxide in the atmosphere. So here is one from the source of the information. But usually we use mostly carbon dioxide equivalent or global warming potential to refer to it. So here 1 kilogram CO2 equals 1 kilogram CO2 equivalent. 1 kilogram methane equals 25 kilogram CO2 equivalent. The term equivalent is used widely, by the way. If we do nitrous oxide N2O, where is here, which is the third one, 1 kilogram of it, equivalent, can you imagine, is 298 kilogram carbon dioxide. Usually the amount of carbon dioxide is generated excessively, by the way, compared to methanes and others. But it's a unit of measurement also. This is what does mean global warming. Not what does mean, anyway, just to have imagination. The earth is burning. All right, we're reaching back to our life cycle analysis first. We want to link it to global warming potential. So you have some types of materials. In fact, that's one as insulator materials, EPS foam slab. I provide a nice slide in the next, which is this one. A rock wall, which is the yellow. It looks like a fiberglass. The colors look almost the same. Polyurethane rigid foam. In fact, from the chemical name, it gives you a direction that is not environmental friendly. It consumes a lot of energy. I believe it like even 100%. And you will search here, you will agree with me. Which is this one. The crop slab, so it's natural. It's almost natural, which is here. Cellulose fiber, which is this one. This one, even the last one looks very natural. Wood wool, which is this one. Sometimes you can even combine two different types of insulation to improve your insulation case. All right, if you have here the different building products in fact insulation, it has various density. It has various thermal conductivity. The lowest thermal conductivity is better in terms as insulator material. So, however, if we take the primary energy demand, so here we find rock wool and cellulose fiber, and probably wood wool is much better in terms of primary energy demand compared to polyurethane and compared to EPS foam slab. In terms of global warming potential, which is a very important part, it's not only in terms of energy, also in terms of global warming, you observe again EPS foam and polyurethane. They generate a very, very huge amount of global warming equivalent CO2 compared to a rock wool, cork slab, and cellulose fiber. This one, just to give you an indication about it, it gives you kind of, I wouldn't say the entire, you are not control, you have very, very, very brief introduction for the topic, but it gives you some hints in terms of selection of building materials where you are supposed to consider, for instance, primary energy demand, global warming potential, etc., including water demand. If you want to minimize water demand, the water demand and the pump that's used, part of the pump will be under energy. The water itself already is supposed also to be considered. Then the situation will be very different. The EPS is still very high, which is the worst to be considered as building material or for insulation, and the same for polyurethane. But here you observe the remaining is also still high. The most interesting part is wood wool. Probably the last option is to ask for the availability and also for the price, and other, if it has other environmental issue, which I explain later. If we take cement and concrete, also you have some of that, the data. But then I take the data a long time ago from one source from it's like written by from Japan anyway. So if truly from Japan, by the way, global warming potential. It was from a conference a long time ago, and water demand. So here you see the amount of global warming potential. So it looks not, the differences are not that big between cement, concrete, mortar, reinforced concrete, and concrete. But then the highest one is cement. It's a good indication to know which one is. And water demand, you have some of the data. The last one is concrete compared to the remaining, but that's it. Then we have several types of bricks and ties. Then you will see the data about global warming potential, water demand. It will be nice if there is additional information about other environmental issues. I show it in separate slide because it's not from the same source, and it wasn't possible to combine all information in one. Then if you want to take thermal conductivity, you will see the lowest one is sandling brick. In fact, the better one, fiber cement roof slide for the roof anyway. You search for the primary energy demand. This one looks very interesting. Again, sandling brick. Global warming, I am not sure what it's minus. A light clay brick. It means they are not generating, they are absorbing a little bit carbon dioxide, or there is some things that compensate the global warming generated from light clay brick. The water demand also shown here. Apparently, the most interesting part, for instance, is light clay brick in most of the aspects when considering the following factors. This is nice to relax if you are tired, and if you are feeling very hot. So the blue ties, so it's very relaxing. Enjoy. Okay, so I see few things. I give you, I let them for reference. Okay, I believe this one is the last part. So, so it will take some time after that. That's it. Okay, how are you now? I should stop and then return back so that you can follow. Otherwise, you'll be very tired. Even though we cannot control now anything. Are you fine? Isabella?
Fine, doctor.
Oh, okay, dokter.
Hello, Fatin.
Okay.
Okay, Isabella. Okay, I search from the name from here as well. Okay.
Okay, doctor.
Ibrahim.
Okay.
Misri. Samur, your name is very difficult. How? Samnur Sida. Samir. Want. Kelvin, are you here? This Ken, are you here, Kevin? Kelvin. Apa khabar? Any news, Kevin? Kelvin. Nor Hasnita. Where are you? Okay, so can we pass down to the next? Oh, Kevin, okay. I received the message. Okay, Nor Hasnita. Hi. All right, so let us, hi, doctor. Hello, Nor Hasnita. Okay, you are still laughing. It's better, to be honest. It's still raining, by the way. Didn't want to stop. I will not tell you how the roads looks near UMS. I promise you, it looks like it's anyway. It's raining. You cannot even walk properly close to the UMS, and they truly mean it. That's the advantage of being at your place and not now in UMS. I imagine the situation later on how it details. If you missed anything from Turkey, let me know. I take a picture and I send it via Schoology. Okay, if you are staying around, should be okay, still okay. You are far, anyway, Kiki missing you, truly missing you. Okay, so we pass to the next. As I mentioned, this one we did the last section for this chapter. So it's about ISO 14040. Why I shall very simple then, because the development of life cycle method is all based on the ISO standard, which is very well known, 14040. In this, I want to search for my other references. All right. So here you observe in life cycle assessment framework according to ISO 14040, it has to have the following. You first will start by goal and scope definition. We will go one by one. For the reason I mentioned, it will be almost I believe it's the last one. And then inventory analysis, impact assessment, interpretation, study outcome. We will start by goal and scope. Then we explain all of it. So remember, life cycle assessment framework is goal and scope of definition, inventory analysis, impact assessment, interpretation of result, and study outcome. So what is your outcome from the study? Goal and scope, life cycle inventory, impact assessment, and finally interpretation. So let us start with scope. Yeah, I expect I do something. I cannot see it. Where is it? Oh, okay, it's here. I will check back if needed. Otherwise, I leave it as reading material. So I explain goal and scope. How I explain, I give you an example which is not available in the PowerPoint. Probably later I will add it. The goal and scope of the analysis. Example, if we have a product, our product is a T-shirt. So, and we want to analyze, or we want to set the goal and scope of the analysis of a T-shirt. So the goal is to make, for instance, the T-shirt more sustainable by reducing its emission during the life cycle. So this one is kind of goal, because probably you do your life cycle analysis. Probably also you will not take all the stages of life cycle analysis in the goal or in the scope is supposed to be well mentioned. If we continue the example about T-shirt, another goal, for instance, for a T-shirt is to manufacture its most efficient, to manufacture it more efficiently. Does it? And in the scope of the study, so the example, as I mentioned, the goal to make the T-shirt, for example, more sustainable by reducing its emission during the life cycle. Probably emission will select carbon dioxide. Another example, for example, is to manufacture the product, which is T-shirt, more efficiently. For our scope of the study, for example, we will look at the T-shirt T-shirt as a whole, analyzing the environmental impact from cradle to grave. So we take all the steps. So this one is the scope of the life cycle analysis. We took at the CO2 emission caused by one T-shirt. So this one, general description about the meaning of goal and scope via example. Of course, there's explanation along the way, so I leave it for you to always read it by your own. So if I want to add anything, I add the one and down in the blue. Limit and extent of the study and set many important assumptions, mainly identification of system boundary, such as the full time of product or one phase of production, functional unit, floor area, data quality, and other limits. So you do need to read it, I believe, carefully, because functional unit is also important. Probably you are not interested to take calculation of the entire building. Probably you are interested also only floor area, etc. But it's exactly the meaning. It looks like similar to FIP or a research study. You do have a goal, and you do have a scope. Scope example, as I mentioned, probably you do it from cradle to grave, and so on. Probably you will not take the entire building. Probably you have some specific types of calculation. Probably you are not interested for all the environmental factors. You are only interested about the emission of carbon dioxide. Again, this one's supposed to be under the goal of the study. Okay, the next part of the life cycle assessment according to ISO 14040 is inventory analysis or life cycle inventory. Okay, so for the life cycle inventory analysis, it looks at the environmental inputs and outputs of a product service. It's what does mean at the end? It's linked to the data collection phase of our life cycle analysis. The data collection example, if you take example of T-shirt, you have like all the what you will be using, like cotton. Here they use various units. The electricity that you will be using, the amount of water, the amount of electricity, the amount of wasted fabric, etc. So I had the environmental inputs and outputs of a product or analysis. Probably will not be using all of the materials. Probably some will be just wasted. It's essentially the data collection. It's very important. Okay, so as I mentioned, this one example for the T-shirt. Here, the procedure for the inventory analysis after the goal and scope, you need to prepare which data you will be collecting. You specify the data exactly like for your case for your assignment. I asked you to collect first the data for my assignment. For your mini project case, I meant the data that you need collected. I just mentioned to you all the devices that uses energy or appliances that use energy in your house. So you do need to prepare first the data. Even the table in empty should be okay. Then you go to data collection. The data collection, since you will collect your data everywhere from your own database, probably from other factors, from other sources. You still need to consider it, and you need to check for the validation of the data. Does it apply for your case, for instance, or not? the unit of the process. You may need to refine your data, the boundary of your calculation, and you repeat again until you finish completely your inventory. So here it contains the data collection and calculation procedure. I believe this one is the best definition. So the second step of the life cycle is inventory analysis. It contains the data collection, which data you will be collecting, and calculation, which calculation procedure you will be using. And is of key importance since this data will be the basis of further study. Because at the end, anything energy used required for the breathing, or the carbon dioxide emitted, or anything linked to the environment, it all is linked to the data itself. Without the data, you cannot do life cycle analysis assessment. So if you have a lot of data, is a good information. Lack of data may result in changing the scope and or the objective of the study. As simple as this. This was some explanation about functional units. Okay, so I just explained briefly, so you may refer later. So we have goal and scope, life cycle inventory, then impact assessment. I think this one is a good example for impact assessment. It's the same for the example of T-shirt. This one you observe the since we assume that the emission of pollutants, so we only consider the equivalent carbon dioxide equivalent. So here the name, like electricity use needed for the T-shirt, the cotton, the natural gas that will be used for burned, that's used for the production, the wastewater that was produced, flesh, water, etc. You have the specific amount, you have the specific unit, then you have done the equivalent carbon dioxide emission, and then you have the percentage for each item. For instance, if I look to here for the global warming potential here, but in terms of percentage, it's obvious that the highest one is electricity consumption, which is 47.2, and the lowest one is carbon black, which is 0.4. Okay, so we refer back to the impact assessment. So I provide more information about it now. So for the case of T-shirt, by the way, so for the T-shirt, we already know what we want to measure. We know that for example, for the amount of carbon dioxide emitted, or the equivalent amount of carbon dioxide emitted. So for this example, sometimes the carbon dioxide emitted equivalent, we call it footprint, or sometimes we call it a global warming potential, footprint. Sometimes we call it carbon dioxide equivalent. Sometimes we call it a global warming potential. So all they are the same. So for our case, we observe that most of the impact comes from electricity. And a very interesting part, if you look at the cotton fiber, you will observe is only 17%, even though the T-shirt is mostly made using cotton. So, but the percentage it ended to be in terms of carbon dioxide emission, it's ended to be very low. Why? Where compared to other factors. Okay, so I repeat what type. We have goal and scope. We have life cycle inventory. You have the impact assessment. The impact assessment is not necessary to be equivalent carbon dioxide. There will be other elements which can affect the environment, which I will provide further information soon. The impact assessment. Okay, in the impact assessment, of course, for the example of T-shirt, and because of the scope of our study, we just narrow it for global warming. So we may have global warming. You may take into consideration all relevant gases that can be, or equivalent carbon dioxide that can be generated from the production, for instance, of T-shirt. You may not have only global warming. Probably your case study is acidification, which has effect at here is global level. This way it has a regional level. Probably eutrophication, which has effect at local level. Probably your product after the ozone depletion, and you are supposed to consider it to minimize its impact, the product impact in the environment. So probably ozone depletion. So and you have here the type of data classification or the gases selection are already shown here. The four are very known in life cycle in life cycle assessment. For that reason, I showed global warming, acidification, eutrophication, ozone depletion. I will explain a little bit more about eutrophication. Acidification, I believe you know what does mean. I think we talked about ozone, probably for chapter 2. Global warming, I explained it before. Okay, what is eutrophication? As simple as this, just focus on the first one. First step. It's overabundance of nutrients added to a water. When you add a lot of nutrition to water, we think that to a water ecosystem, we think that we are doing a favor to the nature, and things are going very well. There's improved environmental, but it's not the case, or not. So whenever they have abundance of nutrition, it will affect in many situations. For instance, it will affect negatively. Why? Example here, you have agricultural runoff, sewage detergents, these nutritions. So here, what happened? The nutrition may affect the oxygen level. It will reduce the amount of oxygen level. So this in turn will affect various plants and species, died fishes, increased plant growth, etc. So overnutrition also may affect may affect the overall environment, which should be considered in life cycle analysis. It doesn't mean all the product. If probably in such case, we may not need it. For example, in civil engineering for breathing, probably we may not need it. So it depends on the breathing and the type of product and the consideration. Product can be even breathing is a product again. This is very interesting about. This one looks quite nice, but compared to my next slide about what is known by eutrophication. So this is a very good example of eutrophication. Boys are enjoying their time there, but then this is a good case. What does it? The negative effect of it. So this is an example. So probably the impact factor may be carbon footprint, acidification, water eutrophication, or other factors as well. Okay, so we're reaching back to our initial part of the slides, or for the ISO 14040 for life cycle assessment framework. So we started by goal and scope. Then I explained briefly about life cycle inventory. Then impact assessment, the one I just finished. It's not necessary to be only carbon dioxide equivalent. Despite that carbon dioxide equivalent is used widely, I believe, in most of the product, because it's generated by many products. So it looks like it's obvious to do calculation of carbon dioxide equivalent while doing life cycle assessment. But other things, as I mentioned to you previously, is supposed to be also considered. Okay, so goal and scope, life cycle inventory, impact assessment. So the next step is interpretation. Okay, for the interpretation part, before I provide further information about, so you should know one thing. I believe you agree with me, because I even in my previous slide we already discussed about, we can always make interpretation of result during the assessment before getting all the information. Probably you have some interpretation of, oh, this one will generate a lot of etc. Oh, this one will generate a lot of carbon dioxide equivalent. So the stage of interpretation can be always done during the assessment. But of course, the most important one is the end of the interpretation. What this means, it means that the interpretation doesn't necessarily have to happen at the very end. But after you collect all your data, you can make the most reliable conclusion and recommendation, because it's based on the entire calculation. But at the initial stages of calculation, you still have some insight about the important information about your study. Okay, so let's read this slide. The final phase of life cycle assessment is interpretation. The purpose of this is to analyze results, reach conclusions, explain limitations, and provide recommendation based on the finding of the preceding phases of the life cycle assessment. Okay, so model information life cycle interpretation is also intended to provide readily and understandable, complete and consistent presentation of the result of your life cycle assessment. Because at the end you have to have an objective, and the interpretation you are supposed to expect to have some problems, and you may need to do interpretation of the result, and probably you may do some changes and redo the calculation one more time, as shown in here. So there is two directions between goal and scope, inventory, impact, and interpretation. After interpretation, probably you want to do some modification. You do modification, and you do the interpretation. So the last one, the last final interpretation is supposed to be study of according to, where is it? Let me reach the page first. Okay, before we reach this one. So for the interpretation part, so according to ISO 14044, which is 2006, when you do interpretation, means it's already explained well in the standard. So you are supposed to identify significant issues based on life cycle assessment, evaluate the study itself. What does mean? How complete your study it is. Probably you have missed some information, some variable, probably you cannot find the data, etc. If it is done sensitively and consistently, you are supposed also to report limitations and suggest recommendations, and also provide recommend conclusions. For example, for the case of T-shirt example, to do interpretation, we know that the biggest impact for the T-shirt was 50%, which come from the electricity used in the production. So based on this information, we can now make better decision. We could, for example, try to reduce the amount of electricity needed in the production, or switch to a source of energy. Probably 50% of energy is huge, and you want to minimize the level of carbon dioxide. Probably you use another source of green energy. Probably you opt to solar energy. Probably 50% of the 50% that from the electricity will be generated using solar energy, given that solar energy, for example, didn't produce carbon dioxide or didn't generate carbon dioxide. This is an easy example for the interpretation of the result, for instance, based on life cycle assessment. Okay, this one I think I mentioned it before, but it's a very important one. The life cycle assessment does necessarily incorporate social implication. Remember when we talk about sustainability according to ISO, we have three main elements, which are environment, what else? Cost implication, and social also implication. So sometimes the social aspect is the least studied so far, so there are not information in abundance as opposed to the two other elements. So however, so life cycle assessment does incorporate social implication. However, social aspects are often interconnected with the environmental aspect of sustainability. Sometimes indirectly they are under environment. Example, health, probably it will be directly under environment, so some they will take it indirectly. It's not accounted for in life cost assessment. However, social life cycle assessment is currently under development, so it's in the progress of being developed. For the reason, mostly the focus will be on the environmental aspect and the cost aspect. But that indirectly is included somehow, though not fully, somehow on the environmental aspect. Okay, this one I didn't do it now for your information. From I believe from previous year, I asked my student to read it. So I just leave it for you later to read it. You will learn some things about the advantages and limitations of life cycle assessment. Probably one of the limitations and probably issues, I wouldn't say limitation, is sometimes the data is not available. When you start the first time, the study also is not easy to be done using life cycle assessment. And there are many important information here you can always refer to. There are tools, usually life cycle assessment. Most of the time, it requires softwares. It's not done using hand calculation. For that reason, usually I didn't provide examples for this chapter. However, I managed to find somehow an interesting application. I started doing it last year with the student. Though it's not directly linked to life cycle assessment, but somehow it helps in life cycle assessment. I think I show it, but you don't need the remaining slides for your revision. You can always take them off. So among the methods, for example, you can use a POP-SYS technique for order preference by symmetry to ideal solution. I just explain short things here. I wonder, I didn't see it that's like this. I don't, the equation looks very complicated, but then when you do your calculation, you will see it's not that complicated. But then you will not be doing calculation for your case. It's like an example. You have some things. Example, you have types of cars, and you have to make decision based on many choices. For this example, it's not linked directly to the life cycle assessment, but it can be done to have a rough evaluation. It's not a developed one, but just a very basic one. So, for example, you have a company, or you want to purchase a car. You have 4 types, and you have 4 criteria. You can choose the car based on style. You can choose it based on reliability, the fuel eco, and cost. You want to make decision and you get lost between because you have many choices. What you can do for the initial calculation, you can take the weightage for each one. If you take the summation of the weightage, you will find equal to 1. Means, okay, my choice, I prefer reliability to be the highest choice. I just rank it. There's no like secret for ranking. It's just rough choices. Then I prefer the fuel eco 03, cost 02, style I am not interested at all. So I will take it 0 point. Probably another one will be different case. Okay, when you have the weight, you will rank your choices. Between styles and the weight somehow in terms of calculation. Yeah, the weight means it will take 0.1% for the style. It will take 0.4 for reliability, for example, 0.3 from fuel economic, 0.2 from cost. Then you have choice between style, reliability, fuel, and cost. For example, I asked you to rank from 1 to 10 your preference for the car, style, reliability, fuel, cost. Probably you fuel cost you rated 10, style you rated 7, etc. It's just it's like a questionnaire, but it's not a questionnaire. It's like a ranking types. From this one, it helps you to choose the one that based on various criteria. At the end of the things, you will choose only one type, for example, of car, and that's it. The calculation is a little bit lengthy. Oh, sorry. The answer is supposed to be last year. Then you have calculation. There's a procedure of calculation. So here there is a coefficient. From that, the one that's close to your criteria, you have many choice criteria made. So you will find one the best and one the worst. The highest one, for example, this one is the best one based on criteria that you made before at the initial stage, and this one is the worst one. This one, it had to make decision when you have many criteria or probably conflicting requirements. It's good to be at least to know about it. If not, we're not doing calculation for it. As I mentioned I started this method last year with my fourth year student. I planned to do it this year, but I ended up to be, as I mentioned, the time may not help to finish all. I think that's all for my part. Thank you. Now it's your time to ask questions. Please write in it if you want. I already provided advices for your assignment.